Hi friends, today I am going to introduce a new topic among you, that is rotational mechanism. In this video, we will cover two topics, what is rotation and kinematics of rotation. At first, I want you to understand what is rotation. Let's start with its basic definitions. Displacement of a rigid body in which a point and the perpendicular line passing through it is fixed. This is called rotation of that rigid body about that fixed line. That fixed line is called axis of rotation. Let's see some examples of the rotation. Rotating fan. In this case, the center of the fan is that fixed point and the line perpendicular to the surface of the fan is that fixed point, which is called axis of rotation. Similarly, in the case of blade of mixture grinder, wheel and pulley of the well. Now, let's see some basic thing about rotation. Each particle rotate in a circular particle. If a object is doing rotation, then each and every particle is doing a circular path except that fixed point. Each particle of body have different displacement, velocity, radius in which it is rotating and some other parameters according to the time, but only that fixed point and the has displacement, velocity, radius in which is rotation as zero, as it has no translational motion, and in fact the earth is also rotating. Now let's start the kinematics of rotation. Considered any irregular figure as shown, each and everything has its, if it is rotating, then each and everything has its axis of rotation or that fixed point. Doesn't depends that the figure is regular or irregular. Let's start some calculations. The line is the line is axis of rotation and the yellow circle is that fixed point. Let's see that it is red, not yellow. Okay, let's see, this is an object. Okay, and this is that fixed point and this is axis of rotation. And this is the let's see, let's consider the figure. You can see we are considering a point P here. Okay, after rotation the position is P naught, so the object to the point moves here to here. Okay, in time T, let's say at T is equals to 0, angle is 0. At this position the angle is 0, but at time T dash the angle is theta, okay. It is, and the particle is covering a circular path as written. Okay, let at t is equals to t dash plus dt and the angle is t plus delta t. This means that this moves slightly down at a slight point of time, so the change in angle per unit time can be written as dt upon with d theta. This acceleration is called regular acceleration. Represent alpha. It is represented by alpha, which is a Greek letter again, and alpha can be written as d omega upon with dt or d double differentiation of d theta upon with dt, we can say. Rotation motion in terms of translation motion. Now we are converting just translation motion and rotation motion, or rotation motion into translation motion. We can see this, we can use this because we know the translation motion as our common experiences, but the rotation is new topic for us, so we just convert the rotation motion into translation motion, which is very easy. So let's start. In translation motion, displacement is written as s, which is displacement. In rotation it is written as theta. Velocity is written as v, but it is written in rotation as omega. Acceleration is a in translation and alpha is in rotation. and we can see these simple formulas in translation. These are also applicable in case of rotation if alpha is constant. Okay, in this a is constant, so v is equals to u plus at, s is equals to ut plus half at square, and v square minus u square is equals to 2as. It can also be written as rotation as omega 2 equals to omega 1 plus alpha t, or theta is equals to omega 1 t plus half alpha t square, or omega 2 square plus omega 1 square. Sorry, it should be minus. I have written this by chance. This should be not plus, this should be minus. Okay, considered sorry. Okay, let's see again. Now just you have seen that v square minus u square is 2as. Similarly, omega 2 square minus omega 1 square is equals to 2as. So changing this variable in translation variable, we can calculate easily as we are used to it, which is translational variables. So we are converting just the rotational variable into translation variable. We can write theta as equals to displacement upon my radius, omega is equals to velocity upon my radius, and alpha is equals to acceleration upon my radius, where r is the radius of the particle. It is rotating. As we have seen that in that figure, it was like that the particle was here. Okay, then the axis of rotation was made like this, and it was covering a circular path. Okay, then, and this point is our that fixed point. Then this is r, the radius of that circle in which it is rotating. Okay, thanks for watching our video. Please like, share and subscribe. It is all about our thing. Please like, share. It was a good video, and you, this is like a general video, and you can share like with the friends, students and everyone.